Hello students, my name is Kaushi Chakraborty. I am a lecturer in electrical engineering at Rajganj Government Polytechnic, Jalpaiguri. Today we will discuss a topic related to the various torques of an indicating instrument. What are the contents which we are going to cover? The contents are the overview of the various torques of an indicating instrument, deflecting torque, its necessity, methods of production, basics of the deflecting system. Controlling torque, its utility, methods of generating controlling torque, and comparison between spring control and gravity control, the two methods of generating the controlling torque. Now, what is a deflecting torque? Deflecting torque or operating torque is that torque which is necessary to deflect the pointer over a particular graduated scale. Now, how is this force produced? We utilize various effects of electricity such as magnetic effect, chemical effect, heating effect, etc. to develop this deflecting torque. Now, the particular method which is required or which is utilized depends upon the type of instrument which we are using. Now, what is controlling torque? Controlling torque is that torque which opposes the deflecting torque. It is equal in magnitude and opposite in direction to the deflecting torque. Now, what is the necessity of controlling torque? Why do we need controlling torque? The controlling torque is that torque which makes the deflection of the pointer for a particular magnitude of current definite. That is, without the controlling torque, the pointer would have deflected full scale irrespective of the current which is being measured, or irrespective of the current at that instant, it would deflect full scale. The controlling torque is that torque which makes the deflection proportional to the quantity which is being measured at that moment. Another utility of controlling torque is that it restores the pointer to zero position once the actuating quantity is removed. If the controlling torque was absent, the pointer would have remained in the full scale or steady position, or the full scale position, and would not have come back to the zero position when the actuating quantity is removed. Now, there are two types of method of generating the controlling torque. One is spring control method and the other is the gravity control method. Now, what is the third torque which is available in our indicating instrument? That is the damping torque. What is damping? Now, when the pointer is a moving system, the moving system oscillates to and fro the deflecting to and fro the equilibrium position. Suppose here we see a picture in which the point steady state position is point O. Now, due to inertia of the moving part, the pointer overshoots this position and goes to point A. At this point A, the controlling force is greater than the deflecting force, and it tries to bring back the pointer to its equilibrium position, that is point O. But again, due to inertia of the moving parts, it overshoots and goes to point B instead of point O. Now, at point B, the deflecting forces are greater than the controlling forces, and it again tries to bring the pointer back to its steady position, that is O. And in this way, the pointer oscillates in and around the final steady state position. Now, these oscillations are at all not desirable, because these oscillations make the process of taking the reading very tedious and time taking. So, we would always want the pointer to come at its final steady state position as quickly as possible without any oscillation. Now, damping forces or damping torque provides these extra forces which bring the pointer to its steady state position without any oscillation very quickly. Now, what are the various methods of producing damping torque? The various methods which are available to produce damping torque are, there are four methods available: air friction damping, fluid friction damping, where we use the fluid viscosity of the fluid Then there is electrical methods, that is the eddy current damping method and the electromagnetic damping method. Now we come to the deflecting system. What is that? We have previously told that the deflecting torque is produced by utilizing various effects of electricity. Now, what are these effects? The magnetic effect, which is present in the which we utilize in the construction of the ammeters, voltmeters, watt meters, etc. Heating effect is utilized in ammeters, voltmeters, watt meters, etc. Electrostatic effect is utilized in voltmeters, etc. Now, the deflecting system or the moving system of an indicating instrument has some requirements. What are the requirements? First, the moving part should be light in weight. The second, what is the second requirement? The second requirement is the frictional forces should be minimum. Now, how can we achieve these two things? One is that the moving parts can be made lighter by using aluminium in the construction as much as possible, and the frictional forces can be reduced. The frictional forces can be reduced by using spindle mounted between jewel bearings and also by carefully balancing the system, which the picture of which we are going to see in the next slide. The power required, why is this all required? That is these two conditions, that is the moving part should be light and the frictional forces should be minimum. These are required so that the power required for the operation of the instrument is small, as the power required is proportional to the weight of the moving parts and the frictional forces. So we always try to keep the weight small, lighter, and the frictional forces as minimum as possible. Now here we see the pictures of the pivot and jewel bearing arrangement and also the balancing system of a indicating instrument, where we use balance weights to balance the moving system. Now, another important ratio which plays a major role in determining the performance and reliability of a measuring instrument, indicating measuring instrument, is the torque weight ratio. Now, higher the torque weight ratio, the more much better is the performance of the instrument. Now, what is the torque? The torque is here is the deflecting torque. It should be high and the weight of the moving system should be low. So here, how can we achieve this higher torque weight ratio? We can achieve this higher torque weight ratio by focusing on the previously discussed requirements, that is the lighter weight of the moving parts and lower frictional force has to be satisfied in order to get a high torque weight ratio. Now we come to the controlling torque and the controlling system. Now, controlling torque, we know that it makes the deflection of the pointer definite for a particular magnitude of electric quantity being measured, and also it restores the pointer to zero position when the actuating quantity is removed. Now, there are two types of control system which we have discussed previously, that is spring control method and gravity control method, which we are going to discuss in detail in the next slide. Now, here we have see the two images of an instrument which uses spring control for achieving the controlling torque. Here we can see that the instrument utilizes two hair springs for achieving this controlling torque. The hair springs are generally made up of phosphor bronze type of material. Now, when the pointer moves, the hair springs which are attached with the moving system gets twisted in the opposite direction of the pointer. Now, there are two springs, so one of the spring gets winded and another gets unwinded, and this produces the controlling torque, which tries to restore the pointer to its equilibrium position. Now in a spring control instrument, the controlling torque is proportional to the deflection of the pointer, that is deflection angle, that is theta. Now controlling torque is denoted by Tc, so it is proportional to some constant K into theta, where K is the spring constant. And in equilibrium position, these two forces, that is controlling force and deflecting force, balance each other at the equilibrium position, that is Tc is equal to Td. Now suppose in PMMC instruments, the deflection is proportional to the current which is passing, so we can conclude that the deflection theta is directly proportional to the current which is being measured. This makes the spring controlled instruments, scales of the spring controlled instruments, a uniform one. That is, the markings on the scales are equally spaced, which is a great advantage in case of taking readings from this type of instruments. Now, what are the springs, the materials with which the springs are constructed, there are some requirements of these materials. First, they should be non-magnetic, so that they are not affected by the magnetic fields which we often use in this type of construction of these type of instruments. Now, they should be free from mechanical fatigue. That is, we know that as the instruments age, the spring constant, that is K, gets decreased, and that's why the strength of the spring also gets diminished. So we should use that type of material which are free from this type of mechanical fatigue, and they should also have a low temperature coefficient of resistance, so that they do not deteriorate with the change of temperature. Now, phosphor bronze is a material which is most suitable in terms of these parameters, and it is a most commonly used material as a spring control material. Now, what is gravity control? In gravity control, we utilize the forces of gravity in achieving the controlling torque. That is, we attach a small weight with one arm of the moving system, and the position of which is adjustable, and by adjusting the position, we achieve the controlling torque due to gravity. Now, in gravity control, the controlling torque is proportional to the sine of the deflection, sine of the angle of deflection. That is, this is proportional of sine of theta. So from that, here we can see that as it is done directly, it is proportional to the sine of the angle of deflection. The scale here will not be uniform as that of the spring control instrument. Now, the degree of control can be adjusted by moving the weight up and down the moving system. That is, by adjusting the weight, we can achieve the degree of control. It can be increased or decreased. Now, here we can see the pictures of gravity control method. That is, the control weight which we are using, and here another picture denotes that how it is the controlling torque is proportional to the sine of the angle of deflection. Here we can see that when the pointer gets deflected from its initial position by an angle of theta, the gravitational force of the weight acts downwards, and it has two components. One is the cos component and the other is the sine component. Now we can see that the sine component is that component which is trying to restore the pointer to its initial position. So we can say that the controlling torque is proportional to the sine of the angle of deflection from this. Now we will discuss the advantages and disadvantages of gravity control vis-a-vis spring control. What are the advantages? The advantage of gravity control is that it is cheap. Here we are only using a particular weight, so it is cheaper than the spring control method. Gravity control is independent of temperature variations, unlike the spring control method. We have seen that with the change of temperature, the stiffness of the spring gets affected and its performance gets hampered. But this is not a problem in case of a gravity control method, and it is also not subjected to fatigue or deterioration, mechanical fatigue or deterioration, as it happens with the aging in case of spring controlled instruments. Now, what are the disadvantages? The first disadvantage, the main disadvantage, is that it has to be gravity control is always used in a vertically mounted instrument. You cannot use it in a horizontally mounted instrument, as the gravitational force is always acting downwards. The second problem is that proper leveling of the instrument is to be done in case of gravity control instrument. Otherwise, the zero adjustment will not be perfect. And the third and the most important disadvantage is that we have discussed previously, that in case of gravity control, as the controlling torque is, or the deflection is proportional to the sine of the angle of deflection, so here the scale will not be uniform, unlike that of spring control instrument. The scale will be cramped at the lower end and equally spaced at the higher end. Now this makes the reading of these instruments more tedious than in case of spring control instruments. So these are these advantages and disadvantages of gravity control in comparison with spring control. With this, we come to an end of this presentation. Thank you very much.